So we're starting 1.7 log scale. So the three specific log scales we're going to discuss are the Richter scale for magnitudes of earthquakes, the pH scale, and the decibel tiering scale. So when we talk about the Richter scale, you guys can read all about that. But basically, it's telling us that every time you move up the Richter scale, it's a power of 10. So every time you get one more magnitude up, you're increasing the magnitude factor by 10, okay, every time. So here is a fancy equation they give you, and it's called magnitude 1 subtract magnitude 2 is equal to the log of the intensities divided. Now, what we do is we rearrange that equation. What we do is we say intensity is equal to this, and then we're able to use the base 10 and log rules. So this is usually just an I by itself. So it's usually just I equals 10 exponent magnitude 1 minus magnitude 2. Now, it depends on which one is going to be subtracted or not. So sometimes we have an x where the first m1 is, sometimes we have x where m2 is. Now, it depends on how we are going to either get an answer that is a fraction. If we get an answer here that's a fraction, that means that we were subtracting a small number, or sorry, small number subtract big number. That's going to give us a fraction for I. Now, if we take big subtract small, that's going to give us a whole number for the intensity, okay? And that's going to be important once we get started. So if you take a look at these, this is the estimate of the different types of earthquakes we usually have throughout the globe. So 2.5 or less usually don't feel it, but the seismographs do record it. So there's about 900,000 every year. 2.5 to 5.4. We get those, but they only cause minor damage. Now, we get about 30,000 of those a year. Some of those are actually misconstrued as being from drilling rigs, some of them as well, too. So you have to be careful there with some of those. Some of them, where they drill into the earth, sometimes that causes earthquakes in other parts of the world, depending. So, 5.5 to 6, damage to buildings and other structures, but it's only minimal damage. We get above 6, and it's going to be causing lots of damage. Now, how many above 6 do we get a year? About 100. Now, about 7 of them, there's only about 20 per year. Now, the Ring of Fire, does everybody know what the Ring of Fire is? Okay, so it's it's where you basically find all of the volcanoes and the plate tectonics of the map, of the globe, the fault lines, yeah. So that's your plate tectonics. So all the fault lines and most of the volcanoes are around the Ring of Fire. And that's where you get tons and tons of volcanoes and different, what is the word I'm looking for? Different islands built and formed from volcanoes, like the Hawaiian Islands or the Fijian Islands, all those kinds. So 8 or greater, there's only about 5 every year, between 5 and 10. That's actually getting exponentially greater. Any idea why it's exponentially growing? Why there's more? Any ideas? Of course, it would be you, Ryder. Global warming? Perhaps. What else?
Cool warming.
Yeah?
It's because of like all the power plants and all the pollution.
Yeah, there's multiple things that we're actually doing and causing to our actual planet that's actually going to be affecting what's going on as well. So it's not just what's naturally occurring in history, or sorry, in the natural nature out there, in nature, it's actually what we're causing it to do because of all of the things that we're doing to it. So do you think every time that they're launching rockets into the ocean just to see how far they can launch, okay, every time they land in the ocean, well, they're blowing up in the ocean. So all of those things are having issues. Those are causing different variations of fault lines, I shouldn't say variations of fault lines, but variations of the magnitude that we see, okay? So this is a scale that we're going to basically talk about. These are the earthquakes that have happened in history, so the ones that have been recorded that we know about. So now we're just going to compare them and see how it works. So everything is going to be based off intensity equals a base 10. So intensity equals 10 m1 minus m2, and that's what we're finding. So is an earthquake of magnitude 8 is how many times bigger than magnitude 7? Well, if 10 is my base, and I go 10, 8 subtract 7, what am I going to get?
Can you put brackets around those?
The exponent, yes.
Yeah.
Yeah. So what are you going to have to do there? Obviously subtract. What's 8 subtract 7? 1. So it's 10 times bigger. Every time you move up on the scale from a 7 to an 8, it's 10 times bigger. Okay? So magnitude 8 is 10 times as intense. When it says as intense, it means stronger. Okay? How much stronger it is. So it is 10 times, so 10 to the 1, it's 10 times as strong. Now, what about a 7 compared to a 3? Well, if you take a 7 compared to a 3, again, all you're doing is taking 7, subtract 3. How big do you get? 10 to the 4th. So 10 to the 4th is 10,000 times stronger. So remember, these are all powers of 10 we're dealing with. Letter C. A magnitude of 4, how much less intense is it than a magnitude of 6? Well, now we've got a negative number because we're taking 4 and subtracting 6. That's going to give us 10 to the negative 2, which is 1/100th as strong. Okay, so it's 1/100th as strong as a magnitude 6. Okay, basically you're dividing by 10 both times, right? Now we're going to compare 4.8 to 6.8. Well, what do you think 4.8 to 6.8 is going to compare as? To negative 2. It's going to be identical to the one right above it. So it's going to be 10 to the negative 2, which is 1/100th as big, 1/100th as strong. All right, now we're going to talk about the ones over here on the right. So it says the 1960 in Chile. So we have to look at 1960 in Chile. He's a 9.5. So I'm writing 9.5 there. It was how many times as intense as the 76 in Italy? So now we got to find 76 in Italy. Where's the Italy? There's 76 in Italy, right there. 6.5. So I've got 9.5 minus 6.5. What's that going to give us? No. Not 9. What are we going to get? 10 cubed. Good. So it's 1,000 times stronger. So it's 1,000 times as intense, even stronger. Now they're comparing that. We're starting again, comparing the Chilean one, the 9.5. We're comparing that to the 83 in Colombia. So let's find the 83 in Colombia. That's at the very bottom here. That guy's a 5.5. So we're going to have a 9.5 minus a 5.5. What's that going to give you? 10 to the 4th. Good. Which is 10,000 times stronger. All right, the 66 in Turkey. So the 1966 in Turkey. There it is, 6.9. So 6.9 in Turkey. I'll change colors so you guys can see it. And the 1933 in Japan. Let's find the Japan one. It's at the top. Yep, right there. Okay, the Japan one was 8.9. So I've got 6.9 minus 8.9. What's that going to give you? 10 to the negative 2, which is 1/100th. Okay? 1/100th is strong. So, there's only 2 things we're going to be doing with these guys. We're either going to be doing our powers of 10, where we're subtracting, or they're going to give us the intensity. If they tell us the intensity, okay, so we're comparing 2 things, like I said. They're either going to give us the 2 magnitudes when we subtract, like we were doing, or they're going to give us the intensity, how much stronger something is. So, when we read the first one, it's saying the Chilean one, 9.5, compared to the Chilean one in 2005. That was about 7.8. So you want to know how much stronger it is. So you're going to say intensity is equal to 10 exponent 9.5 minus 7.8. And then that's what we're going to type in. Yeah. Okay, so that's going to give us 10 exponent 1.7. Now, if you type that in, you actually literally have to type that in, 10 exponent 1.7, and then you're going to round to the nearest 10. So that's going to give you roughly, or it wants whole number, roughly 50 times stronger. Okay, so it's 50 times stronger. So we're actually solving. The next one, same idea. So how many times stronger, so we're solving for intensity, is equal to an earthquake of a 6.8 compared to one that measures 6. So that's going to be 10 exponent 6.8 minus 6, which is going to give us 10 to the 0.8. And you have to type it in exactly like that, 10 exponent 0.8. And it's going to be a decimal, but we want the nearest whole number again. So roughly 6. Okay, so it's 6 times stronger. Okay, and the next one, how many more times stronger is a 5.1 to a 4.9? So again, intensity is 10 exponent 5.1 minus 4.9. So the log scales really aren't that bad. We're just literally subtracting the powers of 10. So that's going to give us 10 exponent 0.2, which is going to give us to the nearest 10th 1.6 roughly. 1.6 times stronger. Okay. So that's roughly how we would do them if we are solving for the intensity. Now we're going to see questions where they're going to give us the intensity and we need to solve for the other size of the other earthquake.
How come you think at the end of the rest of your
Yeah, this one just didn't say to round, and this one was to the 10th I had in my book, so it's to the 10th. That's all I just didn't indicate it here is all. Yeah. I just said it's the 10th of my book, so. Okay, moving on to the next one. So the next example, like I said, it is telling us how many times as intense. So it's telling us how much stronger it is. So when your intensity is greater than 1, when your intensity is greater than 1, you will always set it up like this. You are going to set it up as 10 exponent. Number subtract x. Okay? Because they're talking about a big earthquake subtracting a small earthquake. That's the only way you're going to get an intensity that's greater than 1, where you're taking a big earthquake subtracting a small earthquake. So, they're telling you you've got 375. Well, 375 is greater than 1. So we're going to set up in our equation like this. I equals 10 exponent m1 minus m2. Our intensity is 375 equals 10 exponent. Now we're going to have 7.5 minus x. Now, we are going to convert to log form. So, when I convert to log form, okay, whenever we've got a variable on one side only, this is a variable on one side, exponent only on one side, we've got that situation, we do the conversion to log form immediately, okay? So, this step now, I'm going to write the word log, 375 is equal to, and this is the reason what happens, 7.5 minus x. Because remember, the base stays the base of the log. That's the whole reason we're doing log. You don't have to show the base, because in the word log, the base hides. It's a 10. As long as you're using the 10 as a base, you can hide it as the base on log. Okay? Because that's what it does. It hides if it's a 10. So we have log base 10 of 375. Now, just like we know, we take the exponent and the other guy, and they swap places, because that's how we convert things, right? We just swap places. So now we've done our switcheroo. At this point, we need to solve for x. So, I'm going to show you the long steps, and then I'm going to show you the quick way to do it. I just need to get a new page on here. So, we've got 375 equals 10 exponent 7.5 minus x. We had log 375 equals 7.5 minus x. The quick trick is this. Whenever x is second, this and x switch places, okay? So you would say x equals 7.5, subtract log 375. Now, I'm going to show you the algebraic reason of why that works. We're taking things across the equal sign. All we're doing is literally rearranging an equation. So, I need to have this guy on this side. So I would subtract 7.5, subtract 7.5, and then add it to that guy. Now, that gives me a negative x. Negative x, you're never ever supposed to leave a negative x. It's supposed to always be a positive 1x. So you would divide out that negative 1 in the very end. So when you divide out that negative 1 to both sides, divide the negative 1, divide the negative 1, this guy turns positive like this. The positive in the middle goes negative. Okay? So that's the reason for the algebraic rule. So what you need to remember, though, is you got to take things across the equal sign. So if you remember the quick trick is this. If x is second, just put this guy where the x is. That's all it is. Okay? So now you would literally type that in your calculator. 7.5, subtract log 375, enter. And you're going to get to 1 decimal place because we're finding magnitude of an earthquake, and they're always to 1 decimal place. So what are we going to get to 1 decimal place? 4.9. Okay, check it in your calculator. Make sure you're getting the same thing I am. Say 4.9 is what you should get. Okay. Yep. Okay, on the pH scale, you're either going to be solving for the pH of something, or you're going to be solving for the hydrogen ions. So there's two different equations you get. One is intensity. One is intensity equals 10 exponent pH1 minus pH2. So it's identical. It's just instead of magnitude 1 minus magnitude 2, it's pH1 minus pH2. Okay? So that's the other equation. It's almost identical. The only thing that's different is if now we're talking about solving for hydrogen ions. Okay? When you're given a pH. So we're going to solve both of those so we know what's going on. We need to do a couple examples. So, again, you can read about the pH scale. Hopefully you've all taken biology at least once. So you know that you're anywhere from 0 to 14. The smaller the number, the more acidic. The higher the number, the more alkaline or basic it is. Okay? So, this is in general the pH scale. Next, we want to take a look at, like we did with the other ones, we're going to take some examples of different pHs, and we're going to see how many times bigger they are. Now, just like the magnitude scale was on a base 10. This is also on a base 10. So every time you move to a new pH, it's 10 times either more acidic or 10 times more alkaline. So, we're comparing tomato juice to pure water. So, tomato juice is a 4. And we are comparing to pure water as a 7. We want to say which one's more acidic. Now, we're comparing it in terms of acidity. Who's more acidic? Right, the tomato juice. Now, how much more acidic? He's going to be 10 exponent 3. We're going to take 7 and subtract 4. The reason we're taking 7 and subtract 4 is because we want to find out how much more acidic this guy is. If we want it more alkaline, we would reverse it. Okay? It's backwards to what you actually think. Okay? And it's going to make sense once we work with it. So, this is going to be 10 exponent 7 minus 4, which is 10 exponent 3. So this will be 10 to the 3, which is 1,000 times. So that means tomato juice is 1,000 times more acidic than pure water. Now we're going to compare eggs to water. But now we have to look and see, what are they comparing? Alkalinity or acidity? That's going to tell you which number goes first. So, eggs are an 8. Okay? Pure waters are 7. Now, we want to know eggs are how many more times more alkaline. So they're saying that eggs are more basic than water, which they are. So we want to know how many more times alkaline they are. So this time we're taking the eggs and minusing. So we're going 10 exponent 8 minus 7 here. Okay, because it's bringing alkalinity. So 10 to the 1 is what we're going to get, because 8 minus 7 is 10 to the 1. Oh, that's fine. It can hide, yeah. So it's 10. Eggs again are 8. Now we're comparing it to acidity of pure water. This is the difference of versus doing the alkalinity. We're using the exact same numbers, but it depends on who's subtracting who. Okay? So in this case, if you look at letter B, we did 8 subtract 7. So B was 8 subtract 7. But C is going to be 7 subtract 8. Okay? Because these guys are less acidic than pure water. Okay? These guys are more alkaline. We know that. They're 10 times more alkaline. So that means if we're comparing to acidity, we got to start with the acidity guy. We got to start with the 7. So it's going to be 7 subtract 8. So it's going to be 10 to the negative 1, which is 1/10. Okay? So 1/10. Milk of magnesia is 1,000 times as something as blood. So I want something 10 to the 3 as my answer. So we have milk of magnesia. We're comparing it to blood. And we know blood is how what? What's blood on here? 7.5. All right. And milk of magnesia is 10.5. All right. If they're saying that milk of magnesia is 10 to the 3 times more something than that guy, they took a number that is more something and compared it to something that is more something. Who did they use first? Which number did they use first here? They had to use the big number to subtract the small number. They had to do big subtract small in order to get 10 to the 3. If they got 10 to the negative 3, that means they were comparing blood to milk of magnesia in terms of acidity, or sorry, alkalinity. So here, we've got milk of magnesia is way more alkaline than blood. How come? Because it's got a bigger number, so it's going to be alkaline. Or you might want to say basic. Basic or alkaline, you mean the same thing. Letter E, something is 100 times as acidic as normal rain. So now you're comparing something that's more acidic. So if it's 100 times it's 10 to the 2. So we want the answer to be 10 to the 2. So what is normal rain? Normal rain is at a pH of 5. I want to end up with a pH or a 10 to the 2. So I've got a 5 here. How am I going to end up with a 2 as an answer? Well, we subtracted 3, but which kind of 3? So which way did we go is what I'm asking you. So since we subtracted 3, I could have, is it going to be 8 subtract 5, or is it going to be 5 subtract 3? Okay, or I shouldn't say 8 subtract 5, 6, 7 subtract 5. Okay, so what I'm wanting to know here is, do you understand which number is it going to be because of the alkalinity or the acidity? That's what we're checking right now. This guy got us an answer of a positive 2. And we were comparing normal rain, but we said that it's more acidic as normal rain. Which one's more acidic as rain? 2 times more acidic than rain. That's what it's asking. Who's 2 more acidic than rain? So you're going to take rain and subtract 2. Who do we end up at? Vinegar. So it's going to be vinegar. because he was 10 to the 3. So you had to take something with a big pH, subtract small pH. Okay? The next one. We got eggs. They are 1 over 10,000. That means 1 over 10 to the 4, which was 10 to the negative 4. So we got a negative 4 as an answer. So what were we subtracting? So eggs are at pH of 8. And I got a negative 4. And they're comparing alkalinity. So if I'm 8 and I want something that's more alkaline, I'm looking down the scale at bigger numbers that are more alkaline. So who's more alkaline than my 8? And I have to add 4 to that 8. Where do I end up at? Washing soda for 12. So you end up with a pH of 12. So this would have looked like 10 to the 8 minus 12 equals 10 to the negative 4. That's how that one would have looked. Okay? Because they're comparing something that is way less alkaline than that. Okay? That's how they got that out. Okay, let's flip her over. And now we're going to compare the differences of whether we're going to solve for the hydrogen ions or whether we're going to solve for pH. So it's going to tell us the pHs, and when it says the word respectively, the word respectively means in that order. Okay? So 7, 7.5, and 8.4. 7, 7.5, 8.4. Just label them properly now. So you know the pHs of the substances equal to. So now we're going to compare seawater and its alkalinity to pure water. So seawater to pure water. So we're comparing alkalinity. That means we start with the higher alkaline number. So we're starting with 8.4 and we're minusing 7. So what's that going to give us?
1.4.
10 to the 1.4. Which is going to give us, to the nearest whole number, roughly 25 times. So it's 25 times more basic, more alkaline. Now we're comparing the seawater to the swimming pool water. Same thing, 10 to the 8.4 minus 7.5 this time. So 10 to the 0.9. So how big is 10 to the 0.9? Well, we know 10 to the 1 is 10. So it has to be a number smaller than 10. So how big is 10 to the 0.9? Yeah, it'll round up to roughly 8 times. Yeah. Okay. The next question is a straight up punch at your calculator. Okay? So this one is telling us, they want the pH, but they're telling us the hydrogen ion concentration. So when we're using this equation, we have to use the other one where it's intensity equals, pH equals negative log x. And the x is the hydrogen ion concentration. So if we want to know the pH, we are going to type in negative log, and the x number is going to be that number. Okay? That is our x. So we have to be able to type it in properly. So everybody grab your calculators. And we're going to type it in. Negative log, and then you're going to type that number in. Okay? Everybody type it in. Make sure you're going to round to 1 decimal. Because we want a pH. We're looking for the answer is pH. So what are we going to get for pH here? 3.5, yeah. So the pH equals 3.5. Okay? Now, on the bottom, I'm going to show you how to do question 1, where it says, your turn, please. try these. Number one, I need to show you how to do those ones. Because you don't have a question like that yet. So I'm going to show you how to do those. So on the next page, this is a variation of that pH question. So it's pH equals negative log x. That equation, when they give you the pH and they want to know the hydrogen ion concentration, it's a quick switch. All you've got to literally type in is you put the negative over to the pH side. And how do we get rid of the word log always? We do a base 10. When you do log, log is a base 10. So if you want to get rid of a base 10, you log it so they disappear. And then your answer is the exponent, whatever the exponent is. And that's what these are. So we're using that same log law. It's a log law that we learned. So what we're doing is the quick trick is to do this. X equals 10 to the negative pH. Okay, I'm going to show you the long way to do it, but that's the short way. The long way is this. I've got 5.7 equals negative log x. I have to divide out my negative 1, because it's the negative right here. So you have to divide that negative 1 out. That makes this guy become negative 5.7. So it becomes negative 5.7 equals log of x. And like I said, how do we get rid of the word log? You base 10 it. So when I put a base 10 here, word log gets rid of, x equals that. Okay? So that's how you do those questions. Now, when you type it in, you may get a scientific notation answer, depending on the kind of what your calculator's rounding to. Okay? So, type in 10 to the negative 5.7. What are you guys going to get? So, hopefully everybody got x equals 2 times 10 to the negative 6. That's what you should have had for what you get for this question here. Okay, you should have got 2 times 10 to the negative 6. Okay? Good to go on that? Yep. Okay. I want you guys to try number 2 and 3 right here. Try number 2 and 3. I'll give you a couple minutes. Try 2 and 3 real quick. So if we take a look at this question, because number 2 is going to be the big number subtract small number. The reason is because they're saying how many times more acidic is this small number than the big number. That's what they're asking, is how many times more is this one than the other one. So you're taking 10 exponent 4.1 minus 2.4 here. So it's going to be 10 exponent 1.7 here somewhere, which is 50 times. Okay, so it's 50 times more. Now this guy, whenever they only give you 1 pH or 1 magnitude or 1 decibel, you have to always go back to the equation with the I. They're giving you the intensity, it's 200. So, because remember, this is always I for intensity equals, right? So here, the I is 200. So I have 200 equals 10 exponent, something subtract something. And I have to know which number subtracts the x, or is an x subtracted number. Well, if this number is a whole number, that means x is second. Okay, if it's a whole number, x has to be written second. So 5.4. Okay? So now what we do again, we convert to log form. So log 200 equals 5.4 minus x. What's the quick trick? What do we do here at this step? X is going to switch places with the whole left-hand side. So the left-hand side is going to now be written in where x is. So x equals 5.4 subtract log 200. And that's going to give you the pH of that other substance. And it says it's going to be more acidic, so we need a number that's going to be lower than 5.4. That's how you check whether or not you did it the right way. So we're going to get an answer of x equals 3.1. So the pH was 3.1. Yep. Yes, yes. Yeah, working backward, absolutely. Definitely, for sure. Okay. Any questions so far about pH magnitudes? You're just working with powers of 10, or you're flipping it to log form and solving. Okay? Decibels is next. It's very similar. The only thing that decibels does that's different, if you look at the very bottom of this right here, is the exponent part. The decibels they give you are not in decimal form, so you've got to divide them by 10. That's the only difference. So all the numbers here are way bigger numbers. That's why they have to be divided by 10 in that equation. Okay? So let's take an actual example on the next page. So how many times louder is this than that? Same idea, guys. Intensity for loudness equals 10 exponent, big number, 108, subtract small number, in brackets, all divided by 10. Now, the big important part about this is you've got a fraction exponent now. So what has to happen is you have to subtract the top first, then divide by 10. That's super important. Okay? So subtract, then divide by 10. So that's going to give us 10 exponent 8 over 10, which is 10 exponent 0.8. And that's what you would type in, 10 exponent 0.8. And what are we going to get? 6.3, good job. It's 6.3, louder. So we're talking in terms of loudness now. Okay, the intensity is talking in terms of loudness. Okay, the next one, 97 compared to a 93. Well, same idea. I equals 10 exponent 97 minus 93 divided by 10. 10 exponent 4 over 10, which is 10 exponent 0.4. So 10 to exponent 0.4 is how big? 2.5 times louder. Okay? All right, the next one. We're comparing a power saw to a telephone dial tone. So, we have a 120 subtracting 80. So 120 subtracting 80 gives us 40. Divided by 10 is 4. So intensity is 10 exponent 4, which is 10,000 times. 10,000 times stronger or louder. Okay, so it's that many times louder. Now we're going to take a look at a jet engine at 20 meters. So you're 20 meters away from the jet engine versus the threshold of pain, 125 decibels. So 145 will make your ears bleed. So I equals 10 exponent 145 minus 125 all over 10. So that should give you 10 exponent 2. And how big is 10 exponent 2? 100 times louder. Okay, so 100 times louder. And 30 decibels is how much less than a conversation at 60 decibels. So we've got 10 to the 30 minus 60 all divided by 10. That's the exponent. Exponent -3. That's going to be 1 1/1000th. It's going to be 1/1000th. So a whisper is 1/1000th as loud as a normal conversation. Now we want to know a piano compared to the whisper. We've got a tiny whisper of 22. So 10 exponents, 67 minus 22, all divided by 10. Again, don't forget that's the intensity of loudness. Intensity of loudness, it's all base 10. 10 exponents.
So in intensity, is it always going to be a bigger number? Like for loudness, is it always a bigger number?
Yes, unless you're getting a question like this one where it's comparing a smaller sound and it wants to know how much less it is. But yeah, always, yeah. Almost even with pH and with decibel, or sorry, the Richter scale, almost all of it is going to be big subtract small. Yeah. Probably about 90% of the questions you get. Okay, so what did we get here, guys? It's the 4.5, and it's going to be a big number. It's 5 digits. 31,620, I'll round up to 23. That much times louder. Okay, so the piano is that much times louder than a conversation. Or sorry, a whisper. Okay. Couple things we're going to look at. Broken decay. Now, do they do broken decay with logs? Yes, we do a little bit. And most of them are very, very specific, okay? They'll give you financial ones. Literally, most of these are going to be regressions. And that's going to be in lesson 8 coming up, okay, tomorrow. So most of that is in regressions where they do that. We're going to just jump down to electrical currents here on base E. So, all you're going to do with something like this, with an electrical current question, is you're literally going to stick it into this equation, okay? If they give you a funky equation, you're literally just plugging numbers into the spots, okay? We've never seen this one, we aren't taught this one, but are we able to adapt what we know? You bet we are. So, we're going to use intensity of the electrical current. So I'm going to adapt the equation. I've got I is equal to my initial amount, IO. IO is always your initial amount, remember guys, IO or AO. It's always initial amount, what you start with. And then it's e to the negative kt. All right. I'm going to actually do this on a blank page. So I have a lot of room. So it tells us the value of K is what we're finding. If the current is 25 amps, falls to 2.5 in 0.01 seconds. What happened? So the intensity of what you end with versus what you start with. So we end with 2.5, we're starting with 25. Okay? E exponent negative K times 0.01 seconds. Okay, because that's time in seconds. So far that's what we have. So we always want to solve for our variable. So in this case, we have two variables. We have the letter E and we've got the K. If with letter E, it just means we're going to use ln, but we don't have to do that yet. What we got to do is we got to get rid of that 25 because we need to get that E all by itself. We have to isolate that guy. So we're going to divide out the 25. Okay? Now that's going to give us 0.1 equals E to the negative 0.01 K. All I did was multiply my K and my 0.01. Now we switch to log. Okay, just like we would switch to log, the base stays the base, and then, remember, it's the switcheroo. These two guys are going to switch places. So, the base stays the base, which is ln, it's base E. So we're going to say ln, okay, of 0.1 equals negative 0.01. K. And now what we're going to do is we are going to divide out what's sitting beside K. So we're going to divide out the negative 0.01, divide out negative 0.01. So you would type in ln 0.1, enter, divide by negative 0.01. And what's the nearest whole number? We're going to get a 3-digit number. Okay, so everybody should have got K is equal to 230. Okay? All right. We have one question left in this lesson, and it is a find the error question. So, take a quick look at that bottom one, read through it. Give me a minute to do that, and then we'll take it up together, okay? So read through that bottom question. Okay, so the error is found in line 1. When we're dealing with this equation, it is a variation of this. P1 plus and minus I to the n. When we've got an interest, 12.5%, but it's a reduction of that much. If it's being reduced, it's 1 minus that. So what should they have done? We do have to solve it properly. So this is how we solve this one properly. We would have 50 equals 100, bracket 1 minus 0.125, exponent n. Now, we need to isolate this, which means I need to divide out the 100. I need to get rid of the 100. So I divide them out. So I get 1/2 or 0.5 equals, now I'm going to actually subtract in the bracket. I'm going to get 0.875, exponent, I'll just put an x or n, doesn't matter. And now you just switch to log form. So now we're going to go log, the base stays your base of this, 0.875, the 1/2 equals x. And that's all we got to type in. So now, if you don't have the log base, you'll type in log 1/2, enter, divide by log 0.875. And we're going to get a number that's a decimal. Now, it's 5.2. If this was a multiple choice or numeric response answer, it's actually a great numeric response question. They asked where, because it says during what week. Okay, it wants to know what week. Well, are you going to do, is it week 5 when the sale comes in, or is it after week 5? It's after week 5 because it's 5.2. So you would actually round that up to a 6. It'd be during week 6. Because you finished 5 whole weeks, you're in the middle of week 6. Does that make sense? So that's why that answer would actually be 6. Okay? So you have to look at what the question's asking. Okay, this concludes lesson 1.7.